Hi, I just want to solve one more problem, one more sample problem um, that uses our equation for velocity. And so if you remember, our equation for velocity says this. It says if we want to find velocity, then we take the displacement divided by the time or the change in time. All right, and this is the slope of a graph. We found this from the y-axis, displacement in meters, usually, or miles, and we found time from the x-axis, and we found that velocity was the slope. So this is something you've seen all along, okay? But we can use this to solve problems, and so here is a problem. Um, let's say that we have an object, or let's say that an object wants to go 3,582 meters. Okay, so that is its displacement. It's going to be its displacement. So that's how far it wants to go. All right, but it's going to have a velocity as it does that. It's going to have a velocity of 8 meters per second. All right, then what will the time be? How long will that take for that object to go that far? All right, well, I can go and take my equation. I can substitute into my equation. So I know that the velocity is 8 meters per second. Meters per second down there tells me it's a velocity. So I'm going to write there 8 meters per second. And I know that the displacement is going to be 3,582 meters. And I know that that's going to have to be divided by the change in time to be able to solve this. So now looking at this, how do I solve for the change in time? All right. If you try to put the 3,582 meters on the other side, then on this side of your equation, you would have 1 divided by change in time. And that is not the answer you want. You don't want 1 divided by change in time. You want the change in time, all right, or the change in time here. Okay, and so you can't do that to solve this. To solve this problem, we need to get time all by itself on the other side. We need to have time all by itself in the numerator. And how are we going to do that? How do we get time to go over there? Well, we need to multiply both sides by time or change in time. All right, then it cancels on this side, and that places it on this side. All right, now that does not solve our problem. Now we have meters over here and we've got velocity over here, but we still can't find for time. How do we make it so that we can solve for time? Okay, well, this is a simple math equation. What do we need to do to the 8 meters per second to get it over to the other side? Okay, well, what we really need to do is we need to divide both sides by 8 meters per second. It will cancel here. And then I'm going to put it over here, 8 meters per second. All right. And so it's gone over here, and all I have is change in time equals 3,582 meters divided by 8 meters per second. Okay. Now, is this really going to give us time in our answer? Well, yes, it is, because you can see here that I have meters here and meters here, and they're going to cancel. All right. And what's left over is seconds. All right. It looks like it might be in the denominator, but it's actually not if you do a little bit more math. Okay, so you can ask me about that if you need. But I'm going to solve this problem right now. I'm going to divide the 3,582 meters by 8 meters per second. Okay, and so 3,582 divided by 8 equals, and I get some weird number, which I'm going to round. And so I end up with a final answer of delta t, which is my change in time, equals 3,582 meters divided by 8 meters per second equals 448 seconds. Okay, and so I can solve for how long it's going to take my object to travel. Okay, so this equation can be used. If you know 2 of the parts in that equation, you can use this equation to solve for the third part.